Alright, good morning. Welcome to James's science class. Now, usually I'll go through questions that my students submit to me and I'll discuss them and share my views here. If you're interested, let me also look at your questions. Just share that with me. Okay, so let's get started with a couple of questions sent to me by my students, my primary 6 students. Alright, let's take a look at the first one. If you're interested, of course, to try on your own, you just pause the video, read the question on your own before you attempt it. Alright? Now, the diagram shows the marble being released at a point X on the rim of the bowl. Okay, now there's several words here that you need to take note. When we talk about release, it means that you just let go of something. That means that there is no pushing force whatsoever. The rim means is at the edge of the top and the edge of the bowl. So if it goes down, it's due to the force of gravity pulling it down. Alright? Now, when it was released at point X, what happens? It rolled down the bowl to point Y and then moved up to point Z on the other side of the bowl before rolling back to point Y. So which one of the following graphs show the energy the marble possessed at point X, Y, and Z when the marble rolled down from X to Y and then to Z? So talk about energy conversion from this point, alright, from X to Y, alright, to Z. And, alright, when the marble rolled from this. Okay, let's take a look. Notice that this is the highest point, right? So at this point, the marble would have the maximum amount of GPE. Of course, for PSI purposes, all you need to know is PE, okay? However, I think in my class, I do emphasize that I do teach them that there are different kinds of potential energy. So when we communicate with one another, it's easier when we talk about PE as in it's chemical, it's elastic, or it is gravitational. Basically, PE means stored energy. Now, at this point, that's the lowest point. This is where you get your maximum kinetic energy. That's when it is the fastest. At this point, kinetic energy is equals to 0 because it isn't moving, right? It wasn't moving at a point in time. Now here, let's talk about energy the marble possessed. Now, what kind of energy? So here, talk about potential energy. I'm going to just color it. I think coloring is a useful thing to help us because color stands out. So talk about the pink color part with potential energy. I'm just going to highlight all the potential energy graphs I see here in the bars here, okay? Now, which of the following shows the energy the marble possessed at point X, Y, and Z? Let's carry on. So at point Z now, here, it is also maximum PE. However, this maximum PE is less than the first one. Alright, because it is at a lower height. You can see, right? It is lower in height. And PE is affected by mass of the object and by the height the object is placed in relation to the ground. So therefore, this will have lower PE. When you look at this, we look at X and Z. Alright, I can already rule out option 1 because you can see that X and Z here are at the same level. So based on this, I know that this is wrong. Alright, next one. Now, okay, X and Z, X is more than the PE at X is more than PE at Z. That is correct. However, what is wrong? Two things are wrong here. You notice that here, it says that there is kinetic energy. This white one refers to kinetic energy. There should be no kinetic energy at point X. Alright, there should be no kinetic energy. And when you stop here at Z, there should also be no kinetic energy. So this is another thing that tells us it's wrong. There are other things that are wrong here, but this is enough for us to know the 2 is wrong. Let's go to number 3. Okay, number 3 also shows that there's kinetic energy at X and there's kinetic energy at Z. But the marble actually stopped moving at this point. This when it was released means it wasn't moving at first. This was when it stopped moving. Alright, because it says it's moved up to point Z before rolling back. So it has to stop moving before it can roll back. So for momentarily, for maybe a fraction of a second, it will stop moving. So therefore, answer number 3 is also wrong because there's no kinetic energy there. Let's take a look at this. Now I can understand that this part is correct. If I look at just X and Z, there's more GPE at X than at Z, because it is higher here at X than at compared to Z. And of course, there's maximum of KE here. Now, it's interesting that the graph doesn't show potential energy. I think that's just not to confuse anybody. But by right, if it's above, and I think they take reference to the table as in ground. Of course, table is above the ground. So even the marble here should have some potential energy. I think for the purpose of this question, it's just assuming that the table is at the ground level. So there's minimum PE at point Y. So it didn't show the PE here. So the answer here will be 4. Okay. Now next one. This one will be on, I think, photosynthesis. Now Jane carried out an experiment using, let's see, when you send me pictures, do try to send me clear ones. If it's not so clear, just try again. Using some fishes and hydrilla plants, a stopper was placed at the opening of each test tube. The stopper is usually meant to prevent exchanges of gases. So whatever happened to the gases inside, when the amount of the gases change, when the percentage of it change, due to whether living things are giving out carbon dioxide or plants are taking in carbon dioxide and plants are taking in carbon dioxide, for photosynthesis. All these changes are not due to the environmental factors, but due to whatever is present inside the test tube. Okay, let's take a look at this 4. I see a test tube with only water inside. This is likely to be a control, but let me read on first. I see a test tube with plants inside. Alright, hydrilla plant. So there should be some oxygen bubbles being produced if it's placed under light. And you know a test tube is made of glass, so light can definitely pass through it. Alright, and then photosynthesis can happen. There's no mention this was placed in a dark place, so I assume there will be some light. Here, I see only fish, but no plants. Alright, so I know the fish will be using up the dissolved oxygen inside this test tube here. Here, I see both fish and plant, but it's placed in the black box. When we talk about black box in our science questions, we will always understand it as, unless otherwise stated, always understand it as it is opaque, means light cannot pass through it. That means that if light cannot pass through, there will be no photosynthesis. If there's no photosynthesis, that means that there will be no oxygen produced. Right? Because only in the process of photosynthesis you get oxygen being produced. Now, there's no mention about the aim of the experiment yet, so let's read on to see what is this Jane trying to do with these 4 test tubes. Now, Jane placed 5 ml of solution X. What is this solution X? I'm not sure what it is at the moment. The color of solution X changes in the presence of different amount of carbon dioxide. Oh, so this is what we call an indicator. It's an indicator. An indicator tells is there to test for something. For example, in P5, you will have learned that lime water, that's an indicator for the presence of carbon dioxide. If there's carbon dioxide present in a tube of liquid, then lime water, which is transparent, will turn into a milky, cloudy solution. Alright, as for the chemistry of that, you will learn that in secondary school. If you're interested in color changes, go learn chemistry. Alright. So, okay, so this is an indicator that tests for carbon dioxide, but this is not lime water because lime water only changes into something that is very white and cloudy in the presence of carbon dioxide. In this case, there are multiple color changes. So it says increasing amount of carbon dioxide. There is no arrow to show where is the increment. Alright, there's no mention of the original color of the solution. I don't think this is a PSLE question. So I'm going to assume, because we read from left to right, I will assume that this will be the least amount of CO2. This will be the most amount of CO2. If you're doing this in an exam, do clarify with the examiner in the classroom invigilator, who will then ask the one in charge, hey, on which side is the most and the least? Because there's no mention here. I'm going to assume first. Alright, so if there's very little carbon dioxide, the indicator will show purple. If there's a lot, it will show yellow. all the setups were left in the sun for 3 hours. Remember, 3 hours under sun, we talk about photosynthesis, right? So here, no photosynthesis. So therefore, there will be no change. In this case here, there will be no change in CO2 level. Because there's no living things to take in carbon dioxide, there's no plants to take in. There's no plants to take in carbon dioxide. There's no living things to give out carbon dioxide. Okay? This case here, yes, there will be plants to take in carbon dioxide. So here, I will expect the CO2 level to decrease. Now, of course, for those who understand the process of respiration, the plant will also give out carbon dioxide because the plant is a living thing. Plant need oxygen in order to respire. However, for I think the purpose of the science question here, very often they look at it separately. Yeah? So I will say here that the CO2 level will decrease. So I'm going to assume, once again assume, the rate of photosynthesis is higher than the rate of respiration. So the rate of carbon dioxide used will be higher than the rate of carbon dioxide being produced. In this case here, there are no plants. I do see animals, so this one will be giving up carbon dioxide in the process of respiration. So here I will see increase in the CO2 level. Alright, here because as I mentioned before, there's no photosynthesis, no oxygen, so therefore both the fish and the plant will be giving out carbon dioxide. This one will give out more than this because 2 fish give out this amount of carbon dioxide. Alright, here 2 fish and a hydrogen plant will give out more carbon dioxide. Now, so which of the solution here, and at the start, the solution color of the solution in each test tube was red. So this is the start part, right? As I mentioned, the direction is important, whether which side is increasing, decreasing. It's not mentioned here, so I have to assume right now. I have nobody to ask. Okay, so if it goes on this side, most would means that this I should expect to see D for most carbon dioxide. Alright, based on what we discussed earlier on. And this would be C somewhere here. At the start, you see. So after a while, then after 3 hours, the fish will be giving out more and more carbon dioxide, so therefore the carbon dioxide level will increase. I will expect to see no change A over here, no change. Alright, no change. Decreasing, I should expect to see B either here or here. Okay, so where would I will see therefore B under purple. I see B, I will see purple. Okay, I agree with this student who did this. And then yellow would be D. D is yellow. Okay, so yellow should be this. So let's try again. Purple is this. D is yellow. Alright, yellow. And then, we have the answer, right? But that's a double check. Let's check for C. So C will be, okay, yellow, fine. So it's going to this side, same direction. And A stay as red. Okay? So, in this case here, option 3 is the answer. Alright, option 3. Alright, let's take a look at this question. The setup below shows light shining on 3 sheets, P, Q, and R made of different materials. So when we talk about this light shining on materials, it's often, almost always about the degree of transparency. Whether a material is transparent, whether it's translucent, or whether it's opaque. Now, translucent means it allows most lights to pass through. So one of the sheets allows most light to pass through. Translucent means it allows some light to pass through. Opaque means it does not allow any light to pass through. Alright? And when you ever see a screen, it's almost always about a shadow being cast. In this case here, it is more, the shadow is in the surroundings, and what you see is the patch of light here. And you notice from the options here, each of the sheet has a different shape being cut into it. So, what knowledge do you need in order to solve this, right? And arrange these 3 sheets such that you can get this shadow of this shape. It's not a circle shape, it's not a mix of a circle and a triangle shape or a square shape. Why is it this shape? To do this, you need to fall back on your understanding about shadow formation, how shadows are formed, and how they form different sizes of shadows. To do so, you need to recap, right? 3 things. This is a light source. You need to know idea of light source. This is your P4 light energy lesson. and this is your screen. Screen is where the shadow is formed. Now, let's go to shadow first, because here is about, the size of this is actually not shadow, right? This is actually light patch, but the idea is similar here. So, what is the size? If this is an opaque object first, start off with an opaque object. So, what will be the light? What will be the shadow form here, size of this? If I were to put this here at this distance away from the light source, imagine this black dot is this purple dot is the light source. So, what will happen is this, alright? The light will shine in all directions towards from left to right. Now, the light of course will shine also from towards the object. All the light that shines to the object like this will be blocked. As I mentioned, this is an opaque object right now, okay? It's blocked. The light that shines past it, of course, light shines past it, will just appear as light that is on the screen, so no shadow. So where will the shadow be? A shadow is formed when light is blocked. So this is the size of the shadow. Alright? Now, if the object is now placed further, the same object is placed further away, now the shadow becomes larger or smaller? It will become smaller. Alright, as you can see from what I'm doing here. Now, the size of the shadow will become just like this. So, the further the object is from the light source, alright, the smaller the shadow. Now, why I'm talking about object? Because here, we talk about placing them in different positions, all these sheets. Now, let's flip our thinking a bit. Now, let's say this is not the object, this is the hole. So, let me try to draw this for you to show. Now, this is a hole, torchlight, and now this is a hole here, and the object is around it. Okay? Now, I have another hole, alright, another hole, let's say placed in this position, in this position. Okay? Roughly, okay? The same, let's just double check like this. Alright, this can, alright, roughly the same size hole. Let's say this material is an opaque material and there is the hole. So if I use this idea now, I don't care about the shape first, alright? Don't care about the shape first. This one, when it's placed in this position, further from the light source compared to the one below, alright? There will be a bright patch here. Now, unlike the one before, these are all shadows. In this case here, this will be a bright patch. Alright, it will be a bright patch. I don't have a different, I have different colors. Let me try to use a orange. Okay, it will form a bright patch here of this size. Now, if I were to place it nearer to the light source, how would this be? Larger or smaller patch? Right, let's see if you're right. Light that can pass through it, light can pass through it. Of course, I didn't draw the light. There will be billions of light rays in between these two parts here, because it's a hole. The light can definitely pass through the hole. Okay. Of course, how about the light that shines above this? It will be blocked by the material. So, of course, it will form a shadow. So, the size of this light, okay, that you see here, will be much larger. See? A much larger spot of light. So, what if we now mix up these two? Okay, I put one here. I put another one of the same, let me put it here, okay. So right now the hole is of the same size, as you can see. You can see, right? Same size hole, same size hole. If I put it nearer, because there are three sheets here, right? One will definitely be nearer, one would definitely be much further. One is in between these two. So how would the light be like? This is orange one, right? Now for this, I'm going to draw a different one. Let me try to draw with this. Okay. I'm going to color this light ray here pink. So this light ray here can pass through up to this point before it gets blocked by this object. Let me call this A and call this B, alright? Light can pass through the hole in object A. So if this is a circular hole, I'm not sure what it is, because here I have a circle, triangle, square. I'm just making assumptions here just for discussion's sake. If it's a circular hole and there's no object B, alright, and there's only object A here, then I would expect to see a circular light, a spot of light here. But this is a circular hole, right? But now the problem is being blocked by this. Okay. Then of course, all the light here in this range will be blocked by B. Right, all this purple part will be the light that comes out from the torch will be blocked by B. So only the light here that goes through, that is in orange, okay, here. Only this one that goes through B. Let's say for B is a triangular hole. Let's say B is a triangular hole. Right, I was expect to see a triangular spot of light. Sorry, it shouldn't be like this. It should be like this, okay? Because the whole thing is bright. Then now, although this is a circular hole, I will not see a circular light spot of light because parts of sheet B would have blocked the light that comes through this hole, allowing only the light to pass through the triangular hole. So imagine I flip this sheet around, it looks like this. Right? Only the light that goes through this, right, can reach the screen. Then you will see this triangular hole. So in other words, right, I can put another sheet in front here, and I don't need to care what is the shape of the hole. For it to form a triangular hole here, this one, the last sheet, the third one, must be the one with the triangular hole. Must be. In order to have this. Because whatever cutout you put in front, it could be star shape, whatever shape, right? It just won't cut it because it will be blocked by the other sheets along the way. So I know the last one must be triangle. So that already tells me, hey, this is my answer. Okay, number 2. That is enough to get me the answer. So let's go back to this idea. It comes from the idea learned in P4 about shadows, how you form shadows of different sizes. And the same idea now is being used to form lights, okay, spots of light of different sizes. So use this idea to solve this question. Then you know that the very last sheet can only be one with triangle if you want to form a patch of light that is triangular in shape. Okay? Now, next question. A block of ice was placed in a wooden box as shown in the diagram below. I see ice, I see wood, I see poor conductor of heat. It must be about heat loss, melting, heat gain, and stuff like that. So which of the following best explains why the block of ice melted slowly? So as I mentioned, right, wooden box, alright, talk about ice, talk about melting, therefore it must be about the thermal conductivity of the material, this being a poor conductor of heat. So the wooden box is a good, okay, this is definitely wrong, right? Good conductor is wrong, wood is a poor conductor of heat. The air conduct heat away, this is also wrong, because air is a poor conductor of heat as well. The heat in the wooden box, alright, could not escape to the surrounding air outside the box. The heat in the wooden box This has nothing to do with melting the ice, what? If the heat in the box cannot escape, of course it will melt the ice if it stays inside. But okay, and there's no mention where this is being placed, so I'm not sure about the temperature of surroundings or the whatever. But if you talk about ice, the temperature is 0 degrees Celsius. If this is placed in a classroom environment, let's assume, let's say 28 degrees Celsius, heat from the environment will definitely pass through this slowly until it reaches the air inside and the ice, of course. And then it melts it. The wooden box slow down heat gain. Yeah, you see, the heat is being gained by the ice from the surroundings. Yeah, wooden box slow down heat gain. This tells me that this question is testing about the thermal conductivity of material. That wood is a poor conductor of heat. So it's slow down heat gain by the ice from the surrounding air. This is true. So answer is 4. Okay. Next one. Now Lester created a toy using a spring as shown in the diagram below. So spring. Now this, see this, it must be those elastic spring force, elastic potential energy kind of question. He fixed the toy to the floor, right? Okay, where's the toy? Ring. I suppose ring means you want to pull it, and pull the ring over distance x. Let's see. So he really did pull it. Okay, as it pulls, alright, and then he placed a ping pong ball on this side. So when he let go, then the spring will return its original shape and pushes the ball to the right. Now when Lester released the ring, he measured the distance y, which showed the distance traveled by the ping pong ball on the floor. Okay. The table shows his result. It's interesting that they mark it up to this point. Shouldn't the distance be from the starting point of where the ping pong ball is to where it ends, where it stops moving? So I'm not very sure why this distance starts from this point. Now this is weird. So I think there's a problem here in the way this boy Lester is carrying out its experiment. It should start from wherever the ball stops moving, then let go, then it moves, and so it stops here. This then should be distance y. Again, in exam, if you see things like this that makes you think and wonder, is this a mistake? Do check with the invigilator. When Lester released the ring, he measured this distance. So apparently, what does this mean? He pulled distance x, right? Pulls here. 2 cm means that this spring would have also be compressed by 2 cm. He pull to 6 cm, this definitely will compress more by 6 cm. If pull even more, it will compress even more. The more it's compressed, the more elastic spring force is. The more it's being compressed, the more elastic potential energy is stored in the compressed spring. Alright? And that explains why this ping pong ball can travel a further distance. Okay, sometimes you just go out of focus. Okay. So now let's take the distance, the relationship between distance x and y, and explain why this relationship was observed. So relationship is a simple 1 mark part. Let's try to answer this. What's the relationship between x and y? So this one is increasing, right? This one is also increasing. So as distance x increases, distance y increases. Right? It should be a simple 1 mark for this question because it's just asking for a relationship. You didn't ask for an explanation or conclusion. It's just this. Explain why this relationship is observed. So when you talk about traveling far away, there must be kinetic energy to make it move, Ke, right? So talk about Ke, therefore you must have EP in the first place in the spring. So I will explain it in terms of EPE. As distance x increases, So I need to refer back to my relationship, right? As distance x increases, the spring is compressed more, storing more elastic potential energy that will be converted to more, pardon my handwriting, okay, so you've got to listen, converted to more kinetic energy that moves the ping pong ball over a greater distance. You notice that my starting point and the ending point, right, is definitely following the relationship I talked about earlier. As distance x increases, right, eventually y or distance y increase. Y is the distance traveled by the ping pong ball. So my explanation got to explain why I see this relationship, and I explain it using energy conversion. Okay, let's see this answer. I would say that the relationship part should be correct. Okay, should be 1 mark for this. When distance x increases, the spring in the y is stretched. Stretch is wrong, because it's being compressed. Why is it being compressed? You notice that this is like, I think you need to understand the picture, and I think the person who designed this question should have labeled the center part like maybe rod or something. So when it pulls it, right, what happens is that this one didn't move. So the spring is being pressed against this purple part. Okay, the spring is being pressed against it. So only this part moved out. You notice there's no spring here. So the spring is not being stretched, it's being compressed. See, press, 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 press. So it becomes like this. When pressed, becomes like this, all squashed together, like this, here, or on this side. So the idea that you're talking about stretch here tells me you couldn't interpret this picture correctly. Alright, you talk about stretch, then it's wrong. Yeah, therefore the second part explanation is all wrong. Okay, because if you stretch it, then it will want to return to its original shape. Then it wouldn't be pushing out, it will be going towards each other. If you stretch it, it will go towards each other. This ping pong ball won't move. There's nothing to push it outwards. Okay, so this will be my answer for this. A very long 1 mark for the explanation, but I think this is a complete answer. A few more. Once you are tired, you can go and take a break. And you can always pause and return anytime you want to. Now, Suresh performed an experiment on springs P and Q of the same length. Okay, when it's like this, it must be compressing the spring, I think, because the mass must be being pulled downwards by gravitational force. He measured the compression, therefore, you see, compression, right, of each spring for different masses. More mass will then link to more gravitational force acting on the object with more mass, therefore pressing down with more force on the spring. Right, less mass, less compression. Most mass, most compression. So you can see here, this one is increasing, this one is also increasing. Alright, same here, is also increasing. Now, 2 springs here. Now, which one is a stiffer spring? For this, I'd like you to remember the question on the orange question from the PSL booklet that you all did before. Orange question. Which spring is better for telling the difference in the mass? Know that question? So in this case here, which is the stiffer spring? The stiffer spring is the one that does not compress so much using the same mass. This one compress a little bit. This one compress more using the same mass. So that means that this Q is the stiffer spring. Now, to make it clearer to you, it's like they are the same length, right? Is it same length? So if I put down 5 kg on this spring P, it compresses by 2.9 cm. But if I were to put down a 5 kg on spring Q, which is a stiffer spring, alright, it compresses to 1.9 cm. Compress less, so compresses more. Okay, this one is Q. Also 5 kg on top. Now I understand which spring is the stiffer spring. Let's see what the question wants from us. Oh, that's an application. Suresh sitting on a rocking horse using spring Q. So using the stiffer spring. This is the stiffer spring. Identify the forces acting on Suresh as he sat on the rocking horse. So there are two forces acting on him. One would be the gravitational force pulling him down. Alright. One will be the elastic spring force pushing it up. Because the spring is being compressed, you want to return to its original shape and length. So therefore, it will be pushing upwards. There are two forces acting on him. So this is correct. Elastic spring force and gravitational force. Two answers, a half mark each. After Suresh alighted from the rocking horse, spring Q returned to its original length as shown here. Okay. Explain the change in length of spring Q in terms of force. So you're asked to explain in terms of force. So how will I explain this? I always try to do it on my own first before I look at the answer, either from the students or from the answer key. So remember that the change was from here. There was something on Q. And then later on, when this mass, which is the boy, right, and the mass was removed, it went back to its original. Right? So here there was a force compressing this spring. Here, the force that compressed the spring was removed. So explain the change in length of spring Q. And let me see how many marks is this? It should be a 1 mark question, right? I'll say that when the mass, or when, okay, not when the mass, when Suresh alighted from the horse, the force that he exerted on the spring was removed. Okay, the force that he exerted on the spring was removed. So the spring returned to the original length. Let's check my answer. So when Suresh alighted from the horse here, there will be no marks. Okay, 0 mark, because I'm just copying from the statement here. Right, so no marks for this. The force that he exerted on the spring was removed. Now, let me try to improve my answer. What force was it? The gravitational force. The gravitational force that he exerted on the spring was removed. So remember, there were two forces acting on the rocking horse: gravitational force and elastic spring force. So I'm referring back to this. So the gravitational force exerted on the spring was removed. Okay, so that refers to one part of it. So the spring returned to its original length. You improve. This should be enough, I think. Okay, let me try to bring in elastic spring force. So why do I want to bring in elastic spring force? Because the question asked me to explain in terms of forces. So I need to respond to the requirement of the question. You ask me to use force, so I use force. Okay, you are forcing me to use force. So okay, I will use it. So the elastic spring force in the compressed spring, alright, caused the spring to return to the original length. Okay, let me rewrite, okay, neatly for you to see. When Suresh alighted from the horse, no marks, okay. The gravitational force that he exerted on the spring was removed, and the elastic spring force in the compressed spring caused the spring to return to its original length. Okay, I think this will be my improved answer. So let's take a look at your answer. So when Suresh got up, elastic spring force and the compressed spring enabled it to return its original length. I think this part is correct. The second part here is correct. Alright, your answer is similar to mine for this part. But I didn't talk about the elastic spring force has always been there, right? You didn't talk about the removal of the gravitational force exerted by the person who was on it, Suresh. So that part is missing. So you're going to add in the part about the answer in terms of forces, because you talk about when it got up, this part here, when it got up, and this part, as I mentioned to you, right, has no marks, right? Because you're just talking about repeating this part. So where is the part of gravitational force being removed? So that part needs to be present in your answer. One day, a technician carelessly replaced spring Q with spring P. Remember, spring P is the less stiff spring. So if Suresh sits on it, it will just boom down a lot more. You will just compress the spring a lot more in the rocking horse. Based on the results above, would the height of the spring P be more or less? It will be less. So less is correct. Why? It's more flexible. I wouldn't use the word flexible. Notice I only use the word stiff or less stiff. So I'll prefer to use the word is less stiff. Alright? Than Q. It's less stiff than Q. Right? So it can be compressed more than Q. Okay, this is correct. So the height, okay, this part, the second part here, you're just repeating the first part. This part here, you're just repeating your claim about less. So no need to write this. Alright? So this should be your answer. This part is enough. Okay? Now, some more. Let's see. Mindy set up an experiment to study the digestion of food by saliva in the mouth. So let's see. Okay, I see food and water and saliva. What is this picture? So there's a certain amount of food X and saliva and this. Food X, water. So here no saliva, water, but no food. So let's go to what's digestion. Okay, it's a process where food is broken down into simpler substances. Correct. Now, which two beakers should Mindy compare if she want to find out whether food X can be broken down by the saliva? Therefore, I must have in other words, they're asking you, does saliva digest food? Does saliva digest food? So I need to have one setup with saliva, one setup with no saliva. Okay? One setup with saliva, one setup with no saliva. Then I can tell whether food X can be broken down by saliva or not. Because let's say the food is in this one, where there's no saliva. And after some time, the food can also be broken down into simpler substances. Then you can say, saliva is not necessary, but for food to be broken down, I don't need saliva to break down food, to digest food. So therefore, I'll compare A and B. Alright? Now, in this question, there's no need for you to explain. Alright, just need to state this will do. Yeah, right, so easy. Okay. Now, Mindy carried out experiment to find out how the rate of digestion is affected by the temperature. So right now the change variable is temperature. So everything else must be the same. Temperature is different. So she found out that the rate of digestion is highest when you kept the temperature of the water at 37 degrees Celsius. What is the reason? Let's see. Then, so here the same. Okay. Alright. Now, for this question, I think, alright, the answer is definitely fine. It's a normal temperature of a body. But I think this is a poor question. Poor meaning that it tests you on something that you didn't learn in school, not required in the syllabus. You wouldn't know. For the person to ask this question, it must give you more information. Alright, so you will not be able to tell what is the reason for this. You can infer from this. Yes, it's a very good inference. Alright. This one, you are just stating your claim. Alright, because it's already here. It's given a claim to you. So this is actually not an answer. The rate of digestion is the highest at 37 degrees Celsius. So you are saying the same thing again. So no need to say this. I think it's the best you can give for this answer because you're not needed to know. You haven't learned this. So how can you answer this question? What's the reason? Alright, let's see. Anything else? Oh, still have. How many more pages? Okay, a lot. Now, Mason has a toy that works on batteries as shown in the diagram below. So, it looks like this lady will be spinning around, right? She recorded her observations in the table when she turned on the switches. So, if you turn on both switches, the dancer moves in a circle with the music. So there are two things I can notice here. Sound energy, move, there's kinetic energy. Two things, sound energy and kinetic energy. You turn on A, then there is only sound energy. Turn on B, there's only kinetic energy. So there must be two separate circuits inside. I was thinking of, when you learn in your electrical circuit thing, right? Let's say, remember we use light bulb here, okay? Light bulb, and I use, let's say, a buzzer. A buzzer is like it will ring, It looks like a mushroom, right, my buzzer. So if I turn on this switch, let's say this is called A, then light bulb will light up. If I turn on switch B, then the buzzer will sound, okay? B sound. So it's like this, I need to turn on both, then both will light up and give out a sound. So then I see this is in series, right? Okay, so this one cannot work because it's in series. For current to flow in a circuit, it must be a closed circuit. To close the circuit, you have to then close both of these. Once you close both of these, both will start to function. The music player will start to give out sound, the motor will start to spin the dancer around. You cannot have a case whereby only one is moving, one is not. And you cannot switch on just one switch. If you just on one switch, right, close one switch, this switch will remain open, current cannot flow. Alright, so first we talk about, you must understand the part of current flowing. Second idea is you must be able to control the components inside here separately, and that is only done by parallel circuit. Let's see if the answer talks about it. Okay, I must explain why is her setup incorrect. Okay, so why is it incorrect? And why is it incorrect? Because it must meet the observation that she wants here. So for the toy to work, the movement of the dancer and the music must be controlled separately. Alright, now this may not be my final answer, I'm just trying. Must be controlled separately, meaning that the motor and the music player have to be placed in a parallel arrangement. Right, for the toy to work, okay, let me see. If I just want to reduce my answer to something simpler, for the toy to work, the motor and the music player have to be arranged. Music player have to be placed in a parallel arrangement. Okay, I don't think we need this, no need this, no need this. Okay, for the toy to work, the motor and the music player have to be placed in a parallel arrangement. So I must first show a teacher I know what is correct. Then I can tell why this is wrong. The motor and music player must be placed in a parallel arrangement so to control them separately. Okay, I still must go back to this. Okay, but in what's the name? Mason. In Mason's setup, in Mason's circuit diagram, the components were placed in series. So they meaning the components, and the components meaning the here I'm referring to the music player and the motor, right? So they cannot be controlled separately. And this will explain why they will not see these two movements, separate movements. So if I were to give this answer, right, first I'll give this, and I'll give my 1 mark for this part here. Second part, what's wrong? So they cannot be controlled separately. Okay, in series, good. So what's wrong with that? Okay, your answer is different from mine, quite different, but I think it makes sense. Because you talk about when one switch was turned on, okay, I think your writing here is there will be, right? There will still be an open circuit, good. So current cannot flow for this thing to work. I think your answer is correct. Now, it's different from mine and it's correct. Why? Because you are explaining these two observations. That if you just turn on one switch, nothing will happen because, right, current cannot flow through for either one of these to work. So your answer, I will give you full marks for this. Okay, first you talk about the mistake was in series, all right, and then you explain in terms of the signs what's wrong with this. So 1 mark, 1 mark. I'll give you full marks for this. Although it's quite different from mine. Mine I'm explaining in terms of how it's supposed to work, and then I'm explaining why it cannot work, because it had to be controlled separately for it to work. And this is not good. Good job. Okay. So draw 3 wires complete arrangement to show the observation made by Mason. Okay, I'll draw my paper. So battery, motor, music player. I connect this to this. Okay, I have 2 wires here. I think this question is something wrong with it. You cannot just use 3 wires. Here, let's say I connect these 2. Now I have 2 separate series circuits. Yeah, and that can work. I can have a switch A here, a switch B here. They can control them separately. I switch on both switches. The dancer will move. And I have music. Alright? I don't even need the other battery. Alright, let me see some more. Lintek received the following device after participating in an emergency exercise. The solar panel trap sunlight which powers the device to work as a torch and a radio. Alright, torch and radio. So solar panel will convert the light energy to electrical energy. For this to work as a torch and radio, there will be light energy converted to sound energy from the radio and light energy from the torch. But in between, let's see how it works, right? It should be maybe some kind of, let's see, something is wrong here. Light energy converted into electrical energy that powers the torch, the bulb, and the radio. So light energy from the sun converts to electrical energy inside here, converts to the electrical energy, light energy in the light bulb, and the sound energy in the radio. Okay. Okay. I say okay because very strange to have in the panels. There's no light energy in the panels. Alright. Okay, same. A device can be powered by turning a hand crank. So hand crank is like this. You crank it continuously. Alright, KE is here. So you convert the KE in, alright? So there must be a motor inside for this to work. This hand crank works like the turbine for the hydroelectric power station. You use moving water to move the turbine. In this case, you have no moving water, you have moving hand. A moving hand will keep turning the turbine, and that one is a motor inside, right? You spin a motor inside. So here will be the KE in the hand, convert to the KE in the turbine, and convert to electrical energy in the motor to give electrical energy in the wires and all that. Now, if the torchlight turned on before the radio, that means that the bulb must be placed and the radio are placed in series. Alright, so if I will draw a diagram like this to show you, the battery is here. I have my bulb and I have my radio. Based on the question, we know that they turn on together. Alright, see, as a torch and a radio, see, it plus means it comes up together. Light and sound comes up together at the same time. And you talk about current flow, right? What you learn in your drawing is light flows, current flow from the plus to the minus, so plus. Alright, so it goes to this current flow from the plus sign here out first, right? To eventually the minus. So it flows over here to the bulb first, and then bulb light up. Then electrical energy flow further to the radio, then the radio have sound coming out. Okay? That's why the bulb light up first before the radio. Is this the answer in answer key? No. This is your own answer, right? It's not the answer key answer. So my explanation will be the light bulb is placed and the radio are placed in series, number one, and the light bulb is placed before the radio. So the current will flow to the light bulb first, lighting it up before the electrical current flows to the radio to turn it on. Okay, so that will be how I answer this. Right, those are the questions that you asked me. So I hope that helps you. So sorry it took quite a while.